So hello everyone, today we are going to start our first DSA topic, and that topic is array and pointers. Now I am also going to start with you also that you could also understand, and also what problems I am going to face you should also face probably. So we are going to solve that problems, particularly if you are facing it. Comment down below like this is my problem, I would try to answer it in the comment section. Now the first topic is array and pointers. You have must have listened that we have started DSA, now we are stuck at arrays, just arrays. Why arrays? Because array is a very huge topic. Under array all the topics can come. So particularly solving array problems, if you want to solve, you could solve hundreds of problems of arrays, but it's not that important. We should only focus in the problems like two pointers, sliding windows of the arrays, right? So we should also study about the patterns, not particularly the questions like two sum, four sum. No, don't just go blindly focus on the questions. You need to understand the pattern. So this is the basic class, the first class of our DSA. So we are going to see the basics, right? So if you know the basics already, but you should also watch this video, because anything new which is coming should also be gained by you, should also be, knowledge should come to you, right? uh, yeah, so let's start. So what is an array? Array is nothing. It's a contiguous memory allocation where similar data types are stored. Understood? Here it is a contiguous memory allocation, right? The memory is allocated contiguously in a chain, in a line, whatever you can say. Here the values are there, that is 10, 20, 30, 40, 50. Here the array element is written over here. Basically array of n or array of I is present, where n or I denotes the number of elements present in the array from 0 to that number. If there are 7 numbers, there would be 0 to 6. If there are 10 numbers, 0 to 9. That's indexing in array, right? So now we need to understand the value and the address part of the arrays. Now the value of this particular element of the array, that is array of 0, is 10, and the address of it is 1024. Address is allocated in the computer memory, so you can have the learning about it or cannot. So we are just basically seeing the address and we are denoting it as 1024. You can also take it as 102 or anything like that. But main site knowledge is that the difference between the first element to the second element should be 4. Why 4? Because it is an integer data type, and integer data type gets allocated 4 bits memory in the 4 bytes memory in the particular uh, segment of the address pair. So 102, if the first address of the value 10, then it should be 106, like this only, 106 to 110, 114, 118, right? 4 bits difference should be there. So here array is present. The first address of array of 0 is the address of the array. It is the most important point. The first address of array of 0, like here it is 1024, so the address of the array is 10242. Array plus 1, that is the second element of the array, third element, fourth element, fifth element. So this is all about the array's address value pairs. Now coming to the second part, that is the pointers. Pointers are what? Basically pointers just point a value, right? It points the address to the value, like at this particular address this value is present. If I am trying to store a particular value in a particular address, we need to denote it by a pointer, and that pointer will point to the address where the value is stored. Like here array of pointers is present, you can see it is the what? It is the basically the array, right? Now how this is moving, like this particular array of pointer is pointing to this particular row, this is pointing to this row, this is pointing to this row, and this is pointing to this particular row, right? So this is array of pointers. Now moving to the next page, that is concept of pointer to pointer. What is the basic concept, basic science behind the pointer to pointer approach? A pointer stores the memory address of a variable, right? Basically the pointer, what it does is that it stores the memory address of a variable. A variable I have defined var equal to 1, right? Var equal to 1 I have defined. So the value of var is what? Value of var is 1. Now I can say that I can store my var in a particular location and its value is what? Its value is 1. Now that address storage is done by pointer. The pointer itself is a variable and it is stored in memory which holds the address of the particular variable. We can define a pointer to store the memory address of a pointer variable, right? Now I can like that ptr is equals to pointer, basically is equals to and of var, right? Now what is this particular line meaning? This says that this particular ptr is having the address of var, and now if we want to print like the value of ptr is comma star ptr, now I want the value of this particular pointer which is pointing to, and this will print what? This will print your one value here. So this is all about pointers. Now coming to the first example, example 1, we have defined over here var star ptr and star star ptr, right? Double star means double pointing. One pointer completed, then we go to another pointer. Like first, let's come to the code. It will be easy to understand for you. Where the value is given 3000, ptr we have defined over here, and where, that is it is storing the address of what? Ptr is storing the address of what? Where. pptr is storing the address of what? Ptr. Now come to understand the code. Printf value of var percentage d, that is it will take a integer value, percentage d integer, percentage d integer, done. Now var value is given 3000, it will print 3000 only, easy. Now value available at star ptr will be what? Star ptr means the value that is pointing to that address. We will not print the address, we will print the value which is pointing to that address, right? And where means this address is pointing to which value, right? Here ptr is there, star ptr is there, we want to get the value that the address is pointing to. Here points to where, so definitely it will point to where, and where value is 3000, so we'll also print 3000 over here. And now here this value of star star ptr will be double star ptr, means the value pointed by this which is ptr only, and that particular value ptr is pointing to, so it will go a double above and it will go to 3000 only. You're understanding what I am saying? Like double star ptr means you are pointing once the value which is pointing to the address of ptr, one star, done. Now ptr is pointing to that value preserved by the value address of var. Now we need to move the ptr to remove that one more star which is present here. The ptr has seen 2 stars, we need to remove one more star, so we need to go to var, and after that our one star is removed and var is pointing to 3000, so the value will be 3000 only, done. Now moving to example 2, same type of question only. Printf star u means hexadecimal value, hexadecimal value, hexadecimal value. It will just print what? It will just print the address of all these. So it will be same. Why it will be same? Because ptr is pointing to var, right? And var is pointing to 3000, but we are wanting to know the address of. So if here it wouldn't have been and, then var would be 3000. but here and is present, so definitely we will get the value of the address, and here it is, and it will be same. Why it will be same? Because PTR is there, and PTR is pointing to what? Var. So address of var will be printed, and star PTR means value, or value pointed by the address of PTR, that is var only, so it will be same only. Now what does array mean in 2D array? Up till now we have studied 1D array, that is one dimensional array, where there were single values uh, drawn into an array, where array stored it contiguously, right? Now we are going to study about two-dimensional array, where there will be the concept of rows and columns. Rows of a table, columns of a table. Now it seems to be familiar, right? Now if I want to define array of 10, how I will define? I will just write the numbers from 0 to 9, or any number which I mean to write. But now here we are having B53. So denoting 2D array, the first bracket is for rows, the second bracket is for columns. So there would be what? 5 rows. Means like that. I am just drawing the rough image of it. 1 row, 3 columns. 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. Here we have got total 5 rows, right? 1, 2, 3, 4, 5 and 3 columns. So it is basically I have just drawn with my own conscience, and now this particularly thing can be understood by you all, right? Hope your understanding is just for the basic understanding, it's not that you need to understand the numbers what I have written. You must understand the concept. That's the main thing. We know that a is a constant pointer whose value is the address of the 0th element of the array. I told you just in the starting page only, like what's the value of array of 0 will be the value of the whole array, right? Just like I discussed it here, array of 0, what the value it is storing will be the value of the array, right? Now moving down, here we go. So this particular thing is understood. Now similarly, a plus I is the address of the ith element of the array. A plus I, that is the array's index plus I. Array of 0 plus I is the address of the ith element. Means first element, if I take I equal to 1, then the first element address would be array of 0 plus 1. If array of 0 is 1024, then array of 1 will be 1028, because 4 bits memory is being consumed by the integer, or other way data type will you take, then there would be different bits, as there are different allocations of different data types in particular compilers. Now what is the meaning of B and what is its arithmetic? Now we need to understand this particular B, where we have defined the 2D array. B, what you can say, B is a two-dimensional array, and its particular arithmetic is that it contains how many elements? 1, 2, 3, 5 rows, 15 elements. So here it contains 15 elements, and 5 rows are there and 3 columns are present. So that's the arithmetic. How is a 2D array stored in memory? Now, starting from a given memory location, the elements are stored row-wise in consecutive memory allocations. X is the starting address of the array in memory. C is the number of columns. K is the number of bytes allocated per element array, per array element, right? Now, element Bij will be what? There's a formula. Allocated memory allocation at address X plus I into C plus J into K. So it could be an interview question like, what is the allocated memory allocation at the address this, right? Now for example, let's take an example, right? Element Bij, I take it to be 1, I1 J2. Now X is what? Starting address of the array of element of memory 102. I take X, right? Number of columns. Number of columns I take to be 3, and number of bytes allocated per array element is 4. Alright. Now what will be the allocated memory location at address here? So X is what? X is 102. I is what? I is 1 into C. C is 3. 3 plus J, that is 3 plus 2. That is 5. Right? 5 into K. What is K? K is the number of bytes allocated per array element. Now it will be what? 102 plus 20, that will be 122. I am not that much good in writing, right? So you just understand the concept that particularly matters. This doesn't matter. So this is the allocated memory allocation at the address. That is Bij of 1, 2, where I equal to 1, j equal to 2. This is the allocated memory location. Moving to the arithmetic of B. This one, 2D array. What is arithmetic? I explained you all. I just gave a basic brief, right? Now we are going deep into it. So B is the starting address of the 0th row, right? B00, just B, is starting address of the 0th row. B plus 1, that is here, is the starting address of first row. B20 will be the starting address of the 2th row. In general, B plus I represents the starting address of the ith row. B plus I. Here I, what it means? I is the row number. That is 0th row B plus 0 B, first row B plus 1, second row B plus 2, third row B plus 3, right? In general, this is done. The size of a row will be C into size of int bytes, where C is the number of columns. So size of the row, what will it be? First C, that is the number of columns, and size of int byte, that is 4. And if there are 3 columns, 4 bytes for integers, then it will be 12. It will be the size of that particular row. And if that row is done, we will move to the next. Moving to the next example, right? Int main array, 10 elements, 2D array, 3 rows, 5 columns. Always remember the first value will be the rows and second value will be the columns. Now we will print array. Array 0th element is the first address that computer memory allocates, right? It should be different in mine, it could be different in yours. It depends on the compiler used. Now the difference between the elements will be of how many bytes? 4 bytes, man, because we are using what? Integer array. So integer values will be present. So definitely 4 byte difference, 2604. Done. So A part is done. Coming to the B part, that is a 2D array part. Now you see B plus 1, B plus 2, B plus 3. Okay. Now it is going to store the value of A, B. So here there are present 2 elements. Just now we studied. Just now. What is that? The size of the row will be C into size of int. Here the column size is 5 and the size of integer bits will be 4, which will be equal to 20. So the difference between the particular rows will be 20 bits, right? 20 bits. So if a value is starting from that particular value, the difference between would be 20. Let's see, 7 to 9 to 20, 1 to 20, 30 to 20. Done. So here we understood the concept of difference of address memory allocation. Now moving to type of B. Int B 35. B is a pointer constant of type int. First I is not given, j is particularly given, that is 5. That is a contiguous row of 5 integers. Contiguous row, yes. There is nothing means it's 0. If it is 0, so In particularly indexing, 0 means 1, means 1 row will be present, and in that row 5 columns. No. Yeah, row should be 0, that is 1, and column should be 5. That is 5 contiguous 5 integers. If such a pointer is incremented by 1, it increases by 5 into size of bits. That is column, that particular topic only, right? Column into size of the int bytes. That is 5 is the column, size of int is the particular size of the particular data type which is given. I am telling you all continuously, like if the data type is changed, then definitely the size of bytes will change, right? So that's important to remember. Arithmetic of star b plus I. If b is the address of the 0th row, star b is the 0th row itself, right? Understand first. If b is the address of the 0th row, then star b will be what? Star b will point the particular value to the address, right? The address is containing what value will be unlocked by star b. So if b is denoting the address, then star b will denote the value. Star b will denote the particular value of the bth row. A row may be viewed as 1D array, so star b is the starting address of the 1D array, that is address of the 0th element of the 0th row, right? Star b is the starting address as the 0th row of the 0th element. B plus I is the address of the ith row, that is first row, second row, third row, then b plus 1, b plus 2, b plus 3 will be there. So star b plus I is the address of the 0th element of the ith row, right? For the array, particularly this 3 5 row column, if star b is the address of the 0th element of the 0th row, star b plus 1 will be the address of what? First row of the, not the first element of the 0th row, right? How it is coming? Star b is the address of the 0th element of the 0th row. Then star b plus 1 will be what? Will be the address of the first element of the 0th row. Similarly, star b plus j is the address of the jth element of the 0th row. The difference between b plus 1 and b is 20 bytes. That is row difference. But the difference between star b plus 1 and b star is the size of elements of particular data type, that is 4 bytes. Right? Done. So star b plus I is the address of the 0th element of the ith row. Done? Understood? What it is trying to say? Star b plus I will denote what? Address of the 0th element of the ith row. Done? The star b plus I will denote what? Will denote the jth element of the particular ith row, that is and of bij. So here we come to a conclusion that if we write star b plus I plus j, it will be denoted as and of bij. Yes. Now we come to see some equivalence, like anything that you write from this particular chart will denote this thing. It is very important to know, because in interviews it could be asked like that, how many types you can represent 2D array particular pointers. So that's very important. So yeah, have a screenshot of it. Wait, let me remove so it could be easy for you to take a screenshot. Yeah. Calculation of the address of bij. Now how will we calculate the address of this particular 2D array, right? Now the Cth compiler, that is C compiler, can calculate the address of the jth element of the ith row using the following formula: b plus k into 5i plus j, where k is the size of int. B plus K, that is B denotes what? B is the array, K is the size of int, I is the row, C is the J part, that is column. Yeah. The compiler needs the following value of row and column indices, number of rows, the size of data types. Now passing 2D arrays to function, recap. Yeah, let's see once again. 1D array and formal parameter. Consider declaration int a10, we will contain the 10 elements 0 to 9 indexes. Array name a is a constant pointer. The formal parameter int x, that is array int star x, will denote what? It will be a pointer to a variable of the corresponding type and where the address of an array location is copied into the function. Void sort will print int n, int x array, int n, int star x. There are two information are sufficient for the compiler to calculate the address of xi. That is these two. Formal parameters of 2D array consider declaration int b, row, column. The C compiler needs the following information to calculate the address of bij, that is starting address of b, the data type of int and the column number. Right? Void math add will print int row, int column. It will create a particular 2D array A, particular 2D array B, particular 2D array C. Now we see the example transpose. Transpose of a matrix you would have studied in mathematics, like it would print all the horizontal present elements into vertical and all the vertical present elements into horizontal, right? Yeah. So int pqt loop we will start p0 pqn, like it will do what? It will basically make the matrix transpose, like the diagonal elements will be present in the way they are and all the elements will be moving from vertical to horizontal, horizontal to vertical. So it would be done by this particular thing. This is using transpose, and here we will print the main function. This is the basic function and this is the main part. Here we will particularly print the values and here we will be transposing the values. So transpose a comma 3, 3 is the number of columns, right? And a is the basic array, and that will print the transpose of our matrix. You can understand it, it's not that hard to understand. Dynamically allocating 2D arrays. You may recall we have discussed this particular issue of dynamically allocating space for 1D array using malloc. Malloc, calloc functions you should have seen in C, which is important for you to understand as it allocates some memory to the variable which you are storing in, and if you want to free that particular variable, use the free function. Pros and cons of this approach: the space gets allocated in the global data area called the heap, not on the stack, and hence does not evaporate at the end of the function call. The conventional method allocates space in the stack as part of the activation record and so is not available function calls. Looking back at pointer arithmetics, int star p star q5 star r3 star star s, we are going to understand it. Now, variable p can be used to point to an integer. It is containing the address which is particularly pointing to a particular value. P plus I will be what? P plus I will contain p plus I into the size of the data type. Size of int, here it is as the integer value. We will print the size of int. Variable q can be used to point to an integer array of size 5. Q plus I will mean q plus I multiplied by 5 multiplied by size of int. Array of size 5, here it is given. If it is 1D array, we just multiply the particular size which is given, and if it is a 2D array, we take the number of columns part. Next, x is not a variable. Okay, r is not a variable but a constant pointer name of an array. Each element of the array is an int star. It is not a variable but a constant pointer name of an array. Each statement of the array is an int star. So r plus I, what it will denote? R plus I into size of the int star. Int star is what? Array. Variable s can be used to point a particular location of type int star. Thus s plus I will mean s plus I into star size of int star. Some typical values: size of int 4, size of int star 8, 5 into 4 20. Here star present, so star comma 5, what it was there, r plus I. Okay, r plus I, q plus I into integer size. Right. Okay, now how it is coming 8, you need to understand. Here star is present and here star is present. What does it denotes? Particular address, then to the value. 4 plus 4 8. Particular address, then to the value 8. In star star, address to address, one time done. Now it will point to the value, that is 8. Done. How was 1D array dynamically allocated? How? First, it is a pointer, n value, I value. It is allocated using malloc. It is just giving the memory to the particular variable of p. Array elements can be accessed equivalently as p of I 20. Star p plus I will be 20. Methods to allocate space for 2D array. Variable number of rows, fixed number of columns, variable number of columns but fixed number of rows, both number of rows and columns variable. Dynamically allocating 2D arrays. Variable number of rows, fixed number of columns. Allocating space for 2D array n into 5. We use a pointer type q star q5 to allocate space for the array of n rows and 5 columns. Now what we will do, star q5n, number of rows given, it will scan the number of rows, then q equal to int star 5 malloc n into 5 into size of int. Done. Here we are dynamically allocating the memory of particular q value, that is 0 0 1 0 and 2 0. Done. Here the code is given particularly how it will generate. 5 columns are present, you have given 3 rows input, right? So it will go on to that only. ij what it will become, it will be 3, it will be 5, right? Malloc, the size will be allocated, the memory will be allocated. Now it will print. Like how it will print? First of all, see that I0 J0 value will start from what? This is not rows and columns, right? We are just trying to get the matrix some values, so that we are using this particular I and j variables. Particular row is given your 3 in the input and 5 is the number of columns. So first 0 plus 0, that will be 0. Next 1 1 5, right? Now 0 1 2, then 3. In this way the values will be printed. Now some observations as we have seen. Q points to the 0th row of the 5th element array. Q plus 1 points to the ith row of the 5th element of the array. Star Q is the address of Q00, that is and Q00. Q plus J is the address of the 0th row with the jth index. Q plus I plus J, that is ith row, jth index. Star QQ is Q00. Star Q plus J is Q0J. Star Q plus I plus J is Qij. Done. Dynamically allocating 2D array, fixed number of rows, variable number of columns. Now we will see what we will use in the formula of the columns part. Allocating space for 2D array 3 into m. We can use a pointer array of size 3, where ith element of the array will point to the ith row of length m. Possible to have different number of elements in different rows. Star r3 ic, number of columns we will give. Star d and c, I0 I less than 3 I plus plus r of I int star malloc c star size of int. This will print the values of r0, r1, r2. Here the values will print I plus j. Yeah. So here the value will be printed according to the given code, right? Now we are seeing some observations from here. R of I is the ith pointer which stores the address of the 0th element and the ith row, which is true. So R of I plus j is the address of the jth element with the ith row. Star of Ri plus j is the same of Rij is the jth element of the ith row. True. Both number of rows and columns are variable. Dynamic allocation of R into C. That is here both are variable means dono change. It can change. Both can change. In star star s r c will print the values of rows and columns, will allocate in the memory, and then we will print this particular values. Here 3 5 you have given. Now it will definitely print the value of the row and column. Some observation: s plus I is the address of the ith element of the pointer array. Star s plus I, which is same as s of I, is the ith element of the pointer array that stores the address of the 0th element of the ith row. S of I plus j is the address of the jth element of the ith row. Star s of I plus j, which is the same as s of ij, is the jth element of the ith row. Now we will allocate the memory. Now we will point the array of pointers to allocate we will array of integers for each row. Now it will read the data. Elements access like 2D array elements. Given m and n. 1 2 3 4 5 6 6 7 8 9. We will just create in the space. So this was all about the first lecture of array and pointers. Thank you so much for joining with me, understanding the topic. I know I rushed towards the end, like I wanted to finish this lecture as soon as possible so that it could be also not lengthy for you and it will be easy for you to understand, in order so that basically you could understand and you know feel confident about this topic afterwards. You can understand the code I have given it. I will also try to attach the particular thing with this, that is the PDF, and you know you can understand from it, you can learn from it, and definitely it will help you a lot in your DSA topics. And you know we will come with the next video and it will be of string manipulation, I think so. So yeah, see you in the next one. Stay tuned. You know, comment whatever you like, how you feel about this particular video. If I rush too much, you can also say that, and I know I will particularly improve my teaching skills like understanding skills, so it would be also helpful for you too. So yeah, thank you so much for joining, and I will see you in the next one. Until then, enjoy, relax, chill, do lead code, grind a lot, make some projects, you know, get famous. Thank you. Bye.